Dear students, I welcome you all for fourth chapter of 10th standard science. Under this chapter we are going to study carbon, the chemistry of carbon or otherwise called organic chemistry, and the compounds which are made out of carbon. So this is the chemistry of carbon element. You know, carbon is one of the 105 elements. There are more than 105 elements. Carbon is one among them. It's a very simple element because it is very special element because it plays an important role in the chemistry of life. Almost all living organisms, all living organisms and their body parts and their products contains carbon. Carbon is very common element, and it is the element without which the life cannot exist on this earth. So there are nearly 6 lakhs of material substances that contain carbon. So carbon is the very common element that is present in most of the materials around us. You know, carbon dioxide, you heard carbon dioxide is a gas that is present in atmosphere. Carbon dioxide contains carbon. And living matter, plants, animals, their body, the products that are produced by the living organisms, all the materials of the living organism in their body, they contain carbon. So carbon is one of the most common element that is present in the organic compounds. Organic compounds are the materials, compounds, chemical compounds that are present and that are produced in the body of living organism. All the compounds that make up living matter, living organism, all the compounds that make the living body contains carbon. ಜೀವಿಗಳ ಶರೀರವನ್ನು ನಿರ್ಮಾಣ ಮಾಡಿದಂತಹ ಎಲ್ಲ ವಸ್ತುಗಳಲ್ಲೂ ಕೂಡ ಕಾರ್ಬನ್ ಇದೆ. ಸಚ್ ಆಸ್ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್, ಇಟ್ ಇಸ್ ಅ ಫುಡ್ ಐಟಮ್. ಪ್ರೋಟೀನ್ ಇಸ್ ಎ ಫುಡ್ ಐಟಮ್. ದೆನ್ ಲಿಪಿಡ್, fat, it is also a food item that contains carbon. And nucleic acids, RNA, DNA, so these are all nucleic acids that are present in our body. They also made up of carbon. So carbon, it is very essential, without which life on the earth is impossible. So you cannot imagine the life without carbon. So carbon is the compound. The presence of carbon in the earth is one of the main reasons for the origin of life on the earth. ಕಾರ್ಬನ್ ಇಲ್ಲದೆ ಇದ್ದಿದ್ರೆ ಭೂಮಿ ಮೇಲೆ ಜೀವಿಗಳು ಉತ್ಪತ್ತಿ ಆಗ್ತಾ ಇರಲಿಲ್ಲ ಅನ್ನುವಂಥದ್ದು ಕೂಡ ಒಂದು ಹೇಳಿಕೆ ಇದೆ. ದ ಸರ್ಚ್ ಆಫ್ ಲೈಫ್ ಆನ್ ದ ಎಕ್ಸ್ಟ್ರಾ ಟೆರೆಸ್ಟ್ರಿಯಲ್ ಬಾಡೀಸ್, ಎಲ್ಲೋ ಸ್ಪೇಸ್ನಲ್ಲಿ ಮಂಗಳದಲ್ಲಿ ಜೀವಿ ಇದೆಯಾ ಅಂತ ಕಂಡುಹಿಡಿಯೋದು ಹೇಗೆ ಅಂದರೆ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ಇದೆಯಾ ಅಥವಾ ಕಾರ್ಬನ್ ಕಾಂಪೌಂಡ್ಸ್ ಇದೆಯಾ ಅಂತ. ಸೊ ದ ಸರ್ಚ್ ಆಫ್ ಲೈಫ್ ಆನ್ ದ ಎಕ್ಸ್ಟ್ರಾ ಟೆರೆಸ್ಟ್ರಿಯಲ್ ಬಾಡಿ, extra terrestrial body, terrestrial refers to earth, extra terrestrial body means the celestial bodies like other planets. So they are all called planets, satellites. They are natural satellites, they are called extraterrestrial body. So the presence of life on the extraterrestrial body, ಒಂದು ಗ್ರಹದಲ್ಲಿ ಉಪಗ್ರಹದಲ್ಲಿ ಜೀವಿ ಇದೆಯಾ ಅಂತ ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ we identify by testing whether the carbon compounds are there in them or not. So the number of carbon compounds compared to the compounds of other elements, carbon produce large number of compounds. I already told you of about 6 lakhs of chemical compounds contain carbon. So the total number of carbon compounds if you put together and you put the compounds of other elements on the other hand, the number of carbon compounds is larger than the compounds of other elements. So carbon has some special feature or unique character for the formation of such a large number of compounds. So in this chapter we are going to study the unique character of carbon to produce such a large number of compounds. Then occurrence. If you come to the occurrence means presence, where the carbon is present. Carbon is present in the earth crust. It is also present in the atmosphere in the form of carbon dioxide. It is present in the living organisms such as plants, animals and microorganisms. Now let us look into the percentage of carbon that is present in the different parts of the earth. Earth crust has only 0.02% of carbon. That too, carbon is not in the pure form, it is in the compound form. So carbohydrate, you might have heard calcium carbonate, sunna kelirbodu. Calcium carbonate contains carbon. Then bicarbonates or hydrogen carbonates we have studied in the last chapter. They also the compounds of carbons. Coal, petroleum, they also contain carbon. So all these materials present in the earth crust, but the total percentage of carbon present in the earth crust is of about 0.02%. Then in the atmosphere, in the atmospheric air, carbon dioxide is one of the important gas that is present in the air. Carbon dioxide, the percentage of carbon dioxide in the atmosphere is 0.03%. Life itself is based upon this remarkable chemistry of carbon. I told you, without carbon, you cannot imagine the life. So let us learn something about this wonderful element that is carbon and its chemistry. The chemistry of carbon is also called organic chemistry. Now, after the detailed study of chemistry of carbon, now you can answer a very simple question. The question is like this: name some carbon compounds. So easily you can answer this question. The food which we eat, clothes we wear, plastics, polymers, medicines, paper, drugs, soap and detergent, what we are using in our daily life, all these materials are made up of one or the other carbon compounds. Then what is carbon? Or let us study the chemistry of carbon. In the periodic table, all the elements, all 105 or more than that elements are placed in a tabular form that is called periodic table. So periodic table is a table in which elements are arranged in the increasing order of their atomic number. So if you arrange or if you look into the periodic table, the carbon is located in the 14th group. So totally 18 groups are there, 18 columns are there, 18 columns are there in the periodic table. So carbon is located in the 14th group, that is 14th column. It is the first member of that column. Then if you go to the chemistry second point, carbon is a tetravalent element. Tetravalent element means it has a tetra refers to 4, valent refers to valency. It has 4 valent electrons. Then you must know what is valent electron. Valence electrons are nothing but the electrons that are present in the outermost shell of a atom of that element. So if you write the electronic configuration of carbon, it is very clear. You know, carbon, its atomic number is 6. That means carbon has 6 electrons. So if you write the electronic configuration of carbon, the electronic configuration will be like this: 1s2, 2s2, 2p6. So here there are 2 cells here. This is the first shell. So first shell is represented by 1. This is the second shell. So second shell has 2 electrons in s orbital, 2 electrons in p orbital. Totally how many electrons are there? 4 electrons are there in the outer shell. This is K shell, this is L shell. So this is first cell, this is second cell. So the first cell contains only 2 electrons. The second and outermost cell that contains 4 electrons. The elements which have 4 electrons in the outermost cell are called tetravalent elements. Tetravalency means tetra refers to 4, valency refers to outermost electron. So these are outermost electrons, otherwise called valence electrons. So I told you it is a non-metal. It is present in the P block of the periodic table. So the P block in the periodic table contains most of the non-metals. So non-metals can be seen in the P block of the periodic table that you will learn later. So how to test whether a given substance contains carbon? It is a very simple test. If you heat it, the carbon compounds produce black residue. ನೀವು ಕಾಯಿಸಿದಾಗ ಕಪ್ಪು ಮಸಿಯನ್ನು ಉತ್ಪತ್ತಿ ಮಾಡಿತು ಅಂದರೆ ಆ ವಸ್ತುವಿನಲ್ಲಿ ಕಾರ್ಬನ್ ಇದೆ ಅಂತ ನಾವು ಇಮ್ಯಾಜಿನ್ ಮಾಡಬಹುದು. ಸೊ ನೌ ಟೇಕ್ ಗಿವನ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಆ್ಯಂಡ್ ಹೀಟ್ ಇಟ್. Heat the given compound which is to be tested in a spatula. Spatula is a small spoon-like tool which we are using for heating the chemical substance in the laboratory. If it produces black residue, then we can conclude that it contains carbon. So when you heat a given substance with the help of spatula, if it produces black residue refers to kappu masi, then you can conclude that the given substance contain carbon. So with the knowledge of this, now you can answer these 2 questions. How can you show experimentally that protein, carbohydrate and fats contain carbon? What will be your answer? These are the materials given to you to test whether the given substances contain carbon. Now you have to heat it. So if you heat carbohydrate is present in wheat, it is present in rice, then it is present in almost all cereals. Okay, if you overheat the carbohydrate, it produces black residue. For example, you might have seen if you heat chapati overheated, it is charred, masi agibidutade, because it contains carbohydrate. So proteins and fats are present in the milk. If you heat the milk overheated, it is also charred. So with that knowledge you can say given substance should be heated for some time. If black residues are produced, then you can conclude the given substances contain carbon. So protein, when it is heated, it gets charred, so it contains carbon. Similarly, carbohydrate also, when it is heated, it gets charred, so it contains carbon. Fat also. So another with the same knowledge you can answer another question. When heated flour, ಹಿಟ್ಟನ್ನು ನೀವು ಬಿಸಿ ಮಾಡಿದ್ರೆ, ಮಿಲ್ಕನ್ನು ಬಿಸಿ ಮಾಡಿದ್ರೆ, ದೇ ಗೆಟ್ ಚರ್ಡ್, ಅದು ಕಪ್ಪು ಮಸಿ ಉತ್ಪತ್ತಿ ಮಾಡ್ತದೆ. ಬಟ್ ಸಾಲ್ಟ್, ಉಪ್ಪನ್ನು ನೀವು ಬಿಸಿ ಮಾಡಿದ್ರೆ ವಾಟರ್ H2O ನೀರನ್ನು ಬಿಸಿ ಮಾಡಿದ್ರೆ ದೆ ಡು ನಾಟ್, ಅವು ಮಸಿ ಆಗೋದಿಲ್ಲ. ಈವನ್ ವೆನ್ ದೇ ಆರ್ ಹೀಟೆಡ್ ವಿತ್ a lot of heat is supplied. So even if you supply lot of heat, they do not, what are common salt and water, they do not get charred because they do not contain carbon. See, you know the chemical name of salt, that is sodium chloride. Sodium is there, chlorine is there, no carbon. Water H2O, hydrogen is there, oxygen is there, so no carbon. So these materials, they do not contain carbon. So even if you heat them for a high temperature, they do not get charred, whereas flour, hittu and milk, they contain carbon, so they get charred. Next, let us move on to the next concept. Here onwards, we are going to study little bit different concepts, so we take some deviation in the study. So carbon always contain covalent bond, this is the statement. But what is covalent bond? That we have to study. So covalent bond is a type of chemical bond. Then question arises, what is chemical bond? A chemical bond is a strong linkage between the atoms. This linkage, strong linkage, binds the atom to form a molecule. For example, you know H2O, water is there. H2, two atoms of hydrogen and one atom of oxygen is present in water. One water molecule contains two atoms of hydrogen, one atom of oxygen. There is a strong linkage. ಅವುಗಳ ನಡುವೆ ಹೈಡ್ರೋಜನ್, ನೀರಿನಲ್ಲಿರುವ ಹೈಡ್ರೋಜನ್ ಮತ್ತು ಆಕ್ಸಿಜನ್ ನಡುವೆ ಬಹಳ ಗಟ್ಟಿಯಾದಂತಹ ಒಂದು ಲಿಂಕ್ ಇದೆ, ಒಂದು ಸಂಬಂಧ ಇದೆ, ಒಂದು ಸಂಪರ್ಕ ಇದೆ, ಒಂದು ಬಾಂಡ್ ಇದೆ. ಅದರಿಂದ ಆ ಆಟಮ್ಗಳು ದೆ ಬೈಂಡ್, ಒಂದನ್ನೊಂದು ಗಟ್ಟಿಯಾಗಿ ಹಿಡ್ಕೊಂಡಿದ್ದಾವೆ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಕೆಮಿಕಲ್ ಬಾಂಡ್. ಸೊ ಕೆಮಿಕಲ್ ಬಾಂಡ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎ ಸ್ಟ್ರಾಂಗ್ ಲಿಂಕೇಜ್. ಇದೊಂದು ಸಂಪರ್ಕ ಕೊಂಡಿ, ಯಾವುದರ ನಡುವೆ? ಆಟಮ್ಸ್ ದಟ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಮಾಲಿಕ್ಯೂಲ್. ಒಂದು ಮಾಲಿಕ್ಯೂಲ್ನಲ್ಲಿ ಇರುವಂಥ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಫ್ ಯು ಟೇಕ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, ಒನ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಬೈಂಡ್ಸ್ ವಿತ್ ಟೂ ಆಟಮ್ಸ್ ಆಫ್ oxygen to form carbon dioxide. So the bond, that is the chemical bond that is present in between the carbon and oxygen, makes the carbon dioxide molecule, and it's very strong. It is very strong linkage. Then again question arises, why hydrogen combines together with oxygen to form water? Why hydrogen atoms combine with oxygen to form water? Why carbon atom combines with oxygen atoms to form carbon dioxide? What is the reason behind it? It is to attain the octet configuration. So atoms, after combining with some other atoms of different elements, their atomic configuration, their electronic configuration becomes octet. Octet means they attain 8 electrons in the outermost shell. If any atom attains 8 electrons in its outermost shell, then it acts as noble gas. You know, noble gas do not react with any other atoms so easily because they already have 8 electrons in their outermost cell. So if any element has 8 electrons in the outermost cell, that is called octet configuration or octet state. So to attain octet state, atoms transfer some extra electron to other atom, or they gain electron from other atoms. So by losing or gaining electrons or sharing electrons, electrons to some other atoms, atoms obtain octet configuration. Once they attain octet configuration, they will be stable. So to attain stability, all atoms of different elements, they exchange electron among themselves. ಒಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಕೊಡುವುದರಿಂದ ಆಕ್ಟೇಟ್ ಸ್ಟೇಟನ್ನು ಪಡೆದರೆ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನನ್ನು ಪಡೆಯೋದ್ರಿಂದ ಆಕ್ಟೇಟ್ ಸ್ಟೇಟನ್ನು ಪಡೆಯುತ್ತೆ. ಸೊ ಹಾಗಿದ್ರೆ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ದಟ್ಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್. ಆಗ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ಆಗುತ್ತೆ. ಉದಾಹರಣೆಗೆ ಸೋಡಿಯಂ ಹ್ಯಾಸ್ ಒನ್ ಎಕ್ಸ್ಟ್ರಾ ಎಲೆಕ್ಟ್ರಾನ್ ಇನ್ ದ ಔಟರ್ ಮೋಸ್ಟ್ ಶೆಲ್. ಅದರ ಔಟರ್ ಮೋಸ್ಟ್ ಥರ್ಡ್ ಶೆಲ್ನಲ್ಲಿ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಎಕ್ಸ್ಟ್ರಾ ಇದೆ. ಕ್ಲೋರಿನ್ ನೀಡ್ಸ್ ಒನ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟು ಅಟೈನ್ ಆಕ್ಟೇಟ್ ಸ್ಟೇಟ್. ಅದರ ಹೊರಗಡೆ ಕವಚಕ್ಕೆ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಸಿಕ್ಕರೆ ಕ್ಲೋರಿನ್ ಆಕ್ಟೇಟ್ ಸ್ಟೇಟನ್ನು ಪಡೆಯುತ್ತೆ. ಸೋಡಿಯಂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡಲಿಕ್ಕೆ ರೆಡಿ ಇದೆ, ಕ್ಲೋರಿನ್ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಪಡಿಲಿಕ್ಕೆ ರೆಡಿ ಇದೆ. ಸೊ ದೇ ಕಂಬೈನ್ ಟುಗೆದರ್ ಕೆಮಿಕಲಿ ಟು ಫಾರ್ಮ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್, ದಟ್ ಈಸ್ ಕಾಮನ್ ಸಾಲ್ಟ್. ಕಾಮನ್ ಸಾಲ್ಟ್ ಉಪ್ಪು ಉತ್ಪತ್ತಿ ಆಗುತ್ತೆ. ಸೊ ಹಿಯರ್ one element transfer one electron to another element. By transferring one electron from sodium to chlorine, both the elements or both the atoms attain the octet configuration and both the atoms become stable. So for this reason, elements take part in the chemical reaction and they form chemical bonds. Chemical bonds are of two types. They are ionic bond and covalent bond. So in the next period, we shall study the meaning of ionic bond and the meaning of covalent bond. Thank you for listening the class.